Now this deviation from the ideal behavior, which is shown by these real gases, can easily be expressed in terms of a factor which is called compressibility factor called Z. So what is this Z is? This Z is basically is PV over nRT. So it's a ratio of PV over nRT. And in this case, remember, we take this V as the real. Now, what we do is how to define this Z, which is called compressibility factor. Remember, it's what we can write here is, simply is the ratio of the real to ideal volume. Now what happens is, when the value of this compressibility factor Z was plotted versus P for different gases, we used to have this dotted line for ideal behavior, but we never get any gas to be having what it's Z versus P graph lying completely on this ideal gas graph. What we find is, like for the gases like hydrogen, nitrogen, oxygen, methane and carbon dioxide, the graphs goes like this. Now the graphs can be divided into two categories. One is that the gases which get what Z less than 1, gases which are getting Z less than 1. This is called negative deviation. This is called positive deviation. Now the gases which shows negative deviation, whose graph of Z goes down their ideal behavior, it means what? That their ideal actual volume is more than the real volume. That means that real volume is becoming lesser, which shows that they are compressible. They are developing intermolecular forces of attraction. That is why their volume, real volume is found to be less than the actual one, ideal one, theoretical one, and that is why the Z is going down, and that is why they are having Z what? Less than 1. But this happens at moderate pressure. See, the most important thing in this case is that at moderate pressure, usually the gases are showing negative deviation. At a high pressure, what happens is, yes, molecule comes very close to each other, their intermolecular forces becomes very significant, but then in that case, the volume of the gas molecules also becomes very significant. And then this magnitude of intermolecular forces of attraction in comparison to the total pressure is not much significant, and that is why the volume of the gas molecule dominate, and because of that the graph of the different gases of Z versus P becomes what? More than 1, and that is why the gases are going above this ideal behavior. That is what you need to know. But what is most significant to note is that at a very low pressure, all gases are starting their graph from this Z value 1, which is for the ideal one, which shows that ideal behavior. So what we find is all gases show ideal. All gases means I'm talking about real gases. All real gases shows ideal behavior at very low pressure, because they could have started their graph from here, from more than 1, less than 1, anywhere else. But they all are starting their graphs from what? 1 value, which shows at fairly low pressure they are showing what? Ideal behavior. So all real gases shows ideal behavior at very low pressure, and in terms of temperature it will be very high temperature or at high temperature. And we define this temperature as Boyle's temperature. We call it TB. What is TB? It's the temperature above which all real gases shows ideal gas behavior is called Boyle's temperature. So this is how we define Boyle's temperature, and this is how we explain the deviation of the ideal gases from the ideal behavior to what becoming the real gases, real behavior. This is what we define, or this is how we explain it.